Okay, so this is a Mindstorms demo, and what I'd like to do is show you guys how to do some of the Mindstorms programming. If you have NXT, this is what you'll use to program your robots, and I'm going to go pretty quickly. You may have watched the part 1 on the RoboLab stuff to get some of the basics to talk about it. I'm going to go a little bit faster on this one. If you have questions, we can deal with it in class. You log in, you turn the computer on, it comes up. We can launch Mindstorms. It's going to take a second to load. Okay, and the screen is still building some stuff. We don't need some of these things here. We can click that close box and some of the stuff will go away here. This is the Mindstorms. It looks a lot different than RoboLab, and that's because this is a much newer piece of software here. To start a new program, I'm going to click right here where it says New Program, and I'm going to type in a Mr. E demo right there and click Go, and it's going to create like a new tab right there. And if you've ever done like tabbed web browsing or something else, we can have multiple tabs up. I could have multiple programs here, and this is nice because if I click back here, say, because we need to share computers, sharing the Mindstorm stuff is a lot easier because I could have another program open here and then have another one open here, and we could switch back and forth between different programs pretty easily. So when you guys are grouped up in your programming, you can open each group's program and have them open at the same time, and just make sure that you're using the correct program. It's very drag and drop friendly. I have this symbol here that says move, and that's pretty important. I've got wait for, and that's important, as you'll see, and then I've got another one that's a loop here, and so that's important here too. So I'm just gonna jump right in and basically show you the program that you need to do to make your robot do the task. And remember, your robot's pushing the cans out of the circle, and we needed to get the robot into the circle first. So we're gonna tell it to go forward here. We need a move, and I'm just gonna pull this move out here and drop it. And this is a little bit different than the Mindstorms. Mindstorms, I have different functions for each. It's different than RoboLab. In RoboLab, I have different icons that represent each individual motor. Here, I have one move icon, and down here in the control panel, I can tell it which motors I'm moving. In this case, it defaults to B and C. You could change it to A and C if you wanted to, and turn off B. Some of you may be used to plugging motors into B and C, and so you could just leave it. I can tell it what direction I want to go into. I can tell it if I'm turning. I can tell speed, and even duration is built in right into this control panel. And that makes this program look a lot simpler, but it is still pretty sophisticated, and you'll want to make sure you manage these items in the control panel properly. Okay. Right now it's set to go forward on B and C, and the power is set to 75, and you can drag that up to 100 if you want to, or sometimes we just leave that default at 75. And duration, this is one rotation. The Mindstorm stuff is a little more advanced in that it can sense rotations on the motors. So it's just going to go one rotation around on the main shaft on the motor. I can do degrees of rotation. I can do unlimited, which we'll see in a minute, and I can limit it to seconds in time. But the rotations actually is really nice to use because it can be very precise, and degrees then after that is even more precise. So you can see where that might be. It might be kind of neat to have that. So we can just leave this at rotations. You might want to make that 2 rotations, and this is going to let us go forward into the board to begin with. Do recall that we need to get into the board before we start doing the light sensor and stuff. That'll come in a minute, but we want to get the board in, or get the robot into the circle first. And then now probably the thing we want to do is draw our loop in, and we're going to put the loop in right here. And if I click on the loop, you see I only have a little bit of control here. There's some things I can change, and this is assuming we're going to loop forever, but we get to punch in the time. Since this is measuring, we want to limit this loop for amount of time, and we have 2 minutes to do our contest. 2 times 60 seconds is 120 seconds, and so we can just punch that in there, and now we have our automatic loop that's going to measure how much time we have for doing our contest. We get it into the circle. We only want to do it that one time, and now we're going to go forward again inside the loop, and notice I'm dragging inside the loop and it's going to expand for me. And here now I want to continue going forward, but I don't want to use the rotations anymore. I'm going to take this and go unlimited because I want to go forward until we see that black line. So we're doing a wait for with the light. So I'm going to put the light in here. And once we get this light sensor set up, we're going to want to tell our robot to go backwards. We want to back up into the middle. Okay, and this is here again. This is where precision on the rotations might be nice. It might be 2 or 3 rotations. We'll set it to 2 for the moment, but realize I got to change the direction to backwards. Remember though that backwards and forwards are relative. Because the way you may build your robot, the backwards may be making your robot go forward, or the forward make your robot go backwards. It just depends on how you have it built. And so you do need to be sensitive to that whether or not the forward and backward actually work, the up and down. It may be relative to how you have it wired and built. So you just want to remember that. So we go forward until we see the black line, and we want to back up, and now we need it to turn. And so I'm going to drag in another move, and I'm going to probably maybe we'll do the back up and let it turn as it backs up, and we'll see how that does. And you may want to tweak this a little bit again with the rotations. I'll leave it at 1 rotation here to see how that does, and then we're going to jump around to the beginning. And that's basically your program at this point. There are some things you need to tweak. Okay, you're going to need to go to the view on your robot, the way you have it built, and go into the view area on your robot on the NXT to see what the white area of the board registers on the light sensor, and then you want to see what the black line registers in percentage on the sensor. And you want to drag this threshold to be halfway between what the white and the black read out as on the light sensor. And so it might be in the 30s or 40s, and so I can drag this down a little bit. If they're really close together, let's say your light percentage for the white area is 48 and the black line reads 52, that's really close together, and you may want to consider lowering your light sensor. So that's just like some things you'll have to cover and talk about when you do that, and work as a team. And we'd like you to have 20 percentage points difference between the light and the dark for it to really get a good sense on how to do that. We do want to be able to save our programs, and if I click the save button right up here, we can save, and it's going to say, hey, we're gonna put it in this spot right there, and I can click save. You might get an error. You might have to click on browse and then navigate to the hard drive and users and then the students, and I'm not going to be able to put it in the students, but I'll put it in Eldred C and then put it in documents. And you might have to save it here, in which case I can click OK, because I think you'll get an error if you try to save to the default. A lot of them do. If you get that error and you can't figure out how to do it, no big deal. You come get me and I will help you get it saved. But once you save it that first time, it should save from that point on after that. Okay, so we've got a pretty good program here, and then at this point you want to use the download button. It says download. You don't want to use the download. I think that says download and run. What that will do is it'll download to your robot, and then once the download is complete, it will tell it to run that program right there. And you don't want to do that because it's connected to the computer. It's up on the desk, and you don't want to have it run off the desk and fall to the ground. So just please use the download button and then go and test. You'll have to do this a number of times, and every time you make a change, remember that you have to download the new copy. Let's say I close out of this. How do I find my program again? Well, any recent programs that you create will be in this demo area, the recent program pull-down menu. And you see there's Mr. E Demo, and I click on that and click Go, and then here's my program. And there'll be a lot of programs show up in that pull-down menu for your account because other people in the past have been using that. And that is the basics of how to do the Mindstorm stuff, and that's more or less your program. Again, there's going to be some tweaks you'll need to make for the timing and the speed, and you'll have to do the setup on the light sensor to make sure you have that threshold. If you get this done really quickly, you maybe want to create a new program and maybe duplicate the work you have here, but instead have it turn. You want your robot maybe to turn and have it key on the ultrasonic sensor, so you can have it rotate until it sees another can, and then have it go forward to the black line. And if you can make use of that ultrasonic sensor to see the cans, that would probably be like the upper level of achievement for programming and building the robot. And so if you get this pretty easy because you watch this demo, there's another level of work and difficulty that you can get to by using the ultrasonic sensor. Wait for ultrasonic, and you'll have to calibrate the distance and work with it that way. But if you can get to that, that would be awesome. Okay. Hope you enjoyed the demo. Good luck.